In today's episode, we're going to look at alkali metals and their reactions. Let's have a look at the board. Alkali metals are found on group 1 on the periodic table. So that's the first column on the periodic table. They're highly reactive. They react with water violently, very, very strongly. The reaction that they take with water is on the board. We've got the metal plus water goes to a metal hydroxide and hydrogen gas. This hydrogen gas is flammable, and sometimes we'll actually see a flame from the heat of this reaction. The reaction with sodium and water is in chemical symbols on the board. 2Na plus 2H2O goes to 2NaOH plus H2 or hydrogen gas. Let's have a look at how alkali metals react in the air. Here in front of me, I have a piece of sodium metal. Let's see how this metal reacts with the air. I'm going to cut this piece of metal. As we can see, when you cut the sodium metal, the exposed surface is shiny and metallic. Very quickly, the surface tarnishes. Let's have a look at how alkali metals react with water. On the tile in front of me, I have a piece of lithium metal. We are going to see how this lithium metal reacts with water. I have a basin of water in front of me, which also has phenolphthalein, a pH indicator, in it. This phenolphthalein will turn pink in the presence of an alkali to show us that an alkali has been produced in this reaction. We will also see some fizzing from our lithium metal. As you could see, when lithium reacts with water, we get a fizzing. This fizzing is the production of hydrogen gas. We can also see a change in color in our water due to the pH indicator, which shows that we've produced lithium hydroxide, which is an alkali. Let's look at sodium next. We're now going to look at how sodium metal reacts with water. We have the same setup that we have with lithium metal, with a glass basin full of water and a pH indicator to see our alkali. We should see some fizzing and possibly an orange-yellow flame. As we can see, sodium reacted more vigorously than lithium. We also got the production of hydrogen gas and an alkali formed, in this case, sodium hydroxide. The reaction ended with a brilliant orange flame that we saw right at the end. Let's have a look at potassium. Now we are going to have a look at how potassium reacts with water. Potassium reacts more violently than lithium and sodium. We should see fizzing and a lilac flame. We have the same setup as we had previously for the other two metals, with water and a pH indicator to show the alkali being produced. As you can see, the reaction with water and potassium is more vigorous than that of sodium or lithium. We again see the production of hydrogen gas, and we get an alkali formed, in this case, potassium hydroxide. We also see a lilac flame with this reaction. Let's have a look at the board for patterns of reactivity in alkali metals. As we can see from the reactions we just did, as you increase the atomic number of an alkali metal, you increase its reactivity. So as we go down group 1, we increase the reactivity of the alkali metals. This reactivity is based on having a single electron in its outer energy level, or shell. The single electron makes it easier for the alkali metals to react and lose that electron, causing it to be highly reactive. Another reaction that we can do with alkali metals is to react them with chlorine gas. Alkali metals react with chlorine gas to form metal chlorides. The example I have on the board behind me is sodium plus chlorine gas forms sodium chloride. We can do this with any of the alkali metals. In today's episode, we looked at alkali metals and their reactions. If you liked this video, go ahead and like and subscribe. Please download the notes below and go to positive-charge.co.uk for more great episodes like this.